Okay, now then we will get started on GIS technology, on our final application, GIS technology for land use evaluation. And in yesterday's lecture, we have talked about how to use GIS model to promote the process of land use evaluation. And today, we will have a practice on using GIS technology in land use evaluation. And I will show you how to, and then I will show you how to use GIS models to improve this whole process. Can everybody hear me? Okay. And here, our content will be divided into 4 parts. First, we will have a quick introduction. First, we will have a quick introduction on the practice case. Then we will take some time to learn about the evaluation framework for this case. And after that, we will conduct the evaluation process in SuperMap iDesktop by hand. And after we learned what kind of tools we're going to use and how to set the parameters, then I will show you a demonstration of how to use, and then I will show you a demonstration on how to use geoprocessing automation in the to enhance the efficiency of the land use evaluation process. And now let's get started. For this case, the study area we choose is Chongqing in Western China. It is an economic and population center in the region. And currently, this area faces problems in the quality and development of agricultural land. So the purpose, the purpose for this case is going to find out where are the agricultural land to be protected and plan new areas for agricultural use based on sustainable development goals. And now let's see the evaluation framework we will use for this case. The evaluation framework we're going to use is the 2 criteria evaluation framework recently adopted by China. Here, the 2 criteria refers to environmental resources capability and spatial planning suitability. And here I have a simple definition for these 2 criteria. First is the environmental resources capability. That refers to the capability of a certain land space to support human activities based on the resources in that space. And spatial planning suitability is the suitability of certain land space for varied land use types, including ecosystem protection, agricultural and urban planning. And there's one thing we need to notice that the spatial planning suitability have to be calculated based on the evaluation result of capability. And so our evaluation framework can be divided into 4 parts. First is the preparation part. Here we will design the exact evaluation criteria for our case and pre-process our spatial data and attribute data for the analysis. And then we will use this data to calculate our evaluation factors based on the application of geospatial analysis tool and data processing tool. After we get all the factors, we will grade them based on the evaluation criteria. And after that, we will combine them together to get the evaluation result of capability evaluation for different types of land use. And further, based on the capability evaluation result, we can calculate this, we can conduct the suitability evaluation. And here, as in this case, we're only concerned about agricultural land use. So we will only conduct the evaluation process for agricultural capability and suitability. Now, let's see the factors we will use for the evaluation. Here is the evaluation factors table, and we can see that for different types of land use, we have different factors to be taken into consideration. And for agriculture, there are 6 categories of factors to be taken into consideration. And due to the time limits of our lecture, here we will only choose the evaluation for land resources as the example for this practice. So we will only calculate the factors of slope, height, and soil composition in this practice and use them for the evaluation. We hope this practice will give you a hint on the process and logic behind land use evaluation. And so in the future, you can conduct more complicated evaluation on your own. And now let's look at the data and workflow for this case. Here, in the data we provided to you, there are two data will be used for land use evaluation: DM data and soil set data. Here, DM data contains the height information for our study area, and soil set data is also a raster data. And the pixel values in this raster data represent the percentage of sand in soil for that area. We will use these two data to calculate height, slope, and soil percentage, and evaluate them for land and evaluate them for agricultural use. So here is our evaluation criteria. For agricultural land resources, slope value is the major factor we need to take into consideration. And so we will divide it into 5 classes. Here, class 1 refers to the class of highest capability for agricultural land use. And the greater the value is for this hierarchy, the lower the capability of the land for agricultural land use. And after we have the evaluation result based on slope value, we should also keep in mind that the height of the land and the percentage of sand in soil will both have negative influence on agricultural use. So when the height of land is greater than 2,000 meters, or the percentage of sand in soil is greater than 55%, the evaluation result of the land for agricultural use will be degraded according to these 2 evaluation tables. And so we will grade the value of slope, height, and percentage of soil in sand according to this evaluation criteria. And after that, we will combine these graded factors together. And then for the combination result, we will need to reclassify it. And the purpose for this step is to make classes equal to 5 or greater than 5 or as 5. And therefore, we will have a unified evaluation result divided into classes of 1 to 5. And here are the workflow of our evaluation process. Here, we will use DM data and slope analysis tool to calculate slope values. And then we will use raster reclassify to reclass slope values into 5 hierarchies. After that, we will directly use reclassify DM data and the soil set data. And then we have these three graded factors. Our next step is to combine them together using raster algebraic. And after that, our final step is to reclassify them as to make our final evaluation condition into classes of 1 to 5 as the evaluation result of land resources for agricultural use. So now let's open Supermap iDesktop to complete the work by hand following this workflow. And the data we will use for this practice is stored in the folder named UE application. And here is the data source and workspace for this case. And we will open this workspace in Supermap iDesktop. Here we still choose open file workspace and navigate to the folder for land use evaluation application. And after open this workspace, we can see that in the data source, we have the data set for DM and soil set. We can double click on them to check, and these are the data we are going to use for land use evaluation. And our first step is to calculate the value of slope. To doing so, we will switch to the function tab of spatial analysis. And in the group of raster analysis, we will find surface analysis. And here is our slope analysis tool. Click on it. We don't have to change the parameters. It will calculate the slope based on it will calculate the slope in the unit of angle. And for the result data set, we will rename it as slope and click OK. Here, we can open it up to check. This is the slope. It's the slope value we get. And our next step is to reclassify it. To do so, we will switch to Data tab. And here, in Data Processing group, we will find raster reclassifying. And for the source data, make sure it is the slope value we just calculated. And for the result data, we will rename it as reslope. And here, in the level settings, we can control how many classes we want the slope values to be divided into, and we will set it to be 5 classes, and we will set it to be 5 classes. And here on the left, we can see there are 5 classes, and we can set the value. We can set the value range for each of the class. For the first one, it should be a slope value from 0 to 3, and the target value is 1. And for the second class, we'll change the value. The value range should be 3 to 8, according to the evaluation criteria we discussed in the slides. And for the third one, the range should be 8 to 15. Then it's 15 to 25. And for the final one, it's 25 to maximum. And here we can set the maximum to the maximum of slope value, and usually that should be 90. And now we have set all the parameters. and click OK. Double click on the result. We can see that this is the reclassified slope value. And our next step is to reclassify DM data. So we will still use raster reclassify tool. And for the source data, we will choose DM data in the data source. And for the result data, we will rename it to reheight. And for the range, there will be only 4 ranges. And for the target value, we need to notice that because the value is the degraded value based on the classes of slope, so that won't be the value from 1 to 4. That should be 0, 1, 2, and 5. And now we will set the value range. For the last one, it should be the maximum of that. It should be the maximum of the upper value should be the maximum of height. We will set it to 9,000. It's from 9,000. It's from 4,900 to 9,000. And for the next one, we will set it as 3,000 to 4,900. And for the next one, is from 2,000 to 3,000. And finally, for those of height from 0 to 2,000, their evaluation result, this land won't be degraded for the use for agriculture use. And so we have set the parameters for DM reclassification, and now we can click OK. And here's the result. And we can check the value of this pixel. And so for most of the areas in the study area, they won't be degraded due to their height. And our next step is to reclassify the data, to reclassify the percentage of setting soil data. So the tool we need to use is still raster reclassifying. And the source data should be soil set. And we will rename the result. And for a range, there will be only 3 classes. And the target value need to be changed from 0, 1, and 2. And here we can set the value range for each of the class. For the first one, it's 0 to 45, and then it's 45 to 60. And finally is 60 to maximum. And then click OK. Here is the reclassified result of percentage of set in soil. And so now we have the classified factors for slope, height, and percentage of set in soil. Next step is to combine them together. And the tool we're going to use located in the data tab. And we can find it here, algebraic operation. We can see on the left is a list of data stored in our data source. By double-click on it, we can add it as a variable in our expression. And for this one, and for this case, as the evaluation of slope is a major fact we will use for the evaluation, and the reclassify and the evaluation on height and the soils and percentage of setting soil are actually how the evaluation result of slope will be degraded. So to combine them, we just need to simply end them up. But in more complicated cases, we will need to. But in more complicated cases, we might need to set weights for. We might need to set weights for each of these factors. And click OK. Now, this is our combined result. Double-click on it. We can check this is our combined result. And right-click on this data set. We can check its property. And here, we can see its value range for these pixels. It's from 1 to 7. And as we said before, we want our final evaluation result to be divided into 5 classes from 1 to 5. So here, our final step is to put all the classes equal to or greater than 5 as 5. So here, the tool we need to use is still raster reclassifying. In this case, we have used this tool for 4 times. And for the range, we will set it to, for the level, we will set it to 5. And for the range, for how to set the range, we will switch it from left close, right open to left open, right close. And for the value range, the target value should be 1 to 5. And here we will set it when the value is from 0 to 1 and equal to 1, and they will be regarded as 1. And for the next, for this value, for this value greater than 2, and for this value greater than 1, equal to 2, they will be regarded as 2. And for those others, it's similar. Now for those greater than 4, which means for those equal to 5 or greater than 5, they will all be regarded as 5. And we will set the name of our result data set. Then click OK. Now let's open up the result. This is our final evaluation result for land resources on the use of agriculture use. And here, under the tab of data, we can choose grid value. This tool to check the value of each pixels in this result. And here we can find that for those light blue pixels, they are regarded as class 1 of capability, which means they have the highest capability for agriculture use based on our evaluation. And here we can check those pixels of white. We can check the value of these white pixels, and we can see it's 5, which means they have the lowest capability to support agriculture use. And so according to this evaluation result, we can find out that the southwestern part of our study area has the highest evaluation result for agricultural capability, and the northwest and the northeastern part has the lowest evaluation result of agricultural capability. So for our planning, we need to protect agricultural area in southwestern part of the study area, and to find out if we want to plan new areas for agricultural use, we would generally we will still focus on the southwestern part. And that is the process we need to conduct it in SuperMap iDesktop. And let me see if there are any questions. Okay, I will answer the question about classification process later, and about the data format of in SuperMap. Here, I will directly show you that in SuperMap iDesktop, all the data will be stored in a data source, and in the data source, we can store any kind of GIS data. Like here, we only have the raster data here, but actually we can put raster data and vector data and 3D data together in one data source. And that won't affect our application of this data set. Also, if you want to separate them, you can create multiple data sources, and in one workspace, it can connect it to multiple data sources. Like here, we already have the data source named as land use evaluation, but we can also right-click on data source node and choose open file data source. And so we can navigate to where we have other data source. Like we can add the data source for our previous practice case. And it was ended. We can use data set from both data source in one workspace to complete our work. And then let's move back to our slides. Now we have complete the whole workflow in SuperMap iDesktop. And we also have instructions on each of the steps in the slides, so you can check it if you want to complete this work by yourself. And as we have discussed, and as I have introduced to you yesterday, that we can use geoprocessing automation to enhance the efficiency of land use evaluation process. Now we will have a demonstration on how to do that. Here, the geoprocessing automation is a tool we can use to create a GIS model. And if you want to use this tool, you can choose to create your model in SuperMap iDesktop X or SuperMap iServer. Here, supermap iDesktop X is quite similar to supermap iDesktop, and it is capable of processing data. It is capable of processing data, processing relatively small size of data stored in local PC. And if you are dealing with big data, it's better to choose supermap iServer, and it can analyze data stored in the server with distributed computation technology. And in this case, we will create our model for land use evaluation in supermap iDesktop X. And this is the model we created for the evaluation process of the case. And now I'll show you the demonstration on how this model is created and how we can get the result from it. Here we can still see this is the data we used we used in the evaluation process, and we will create a new model building window. And from the right, we can drag from the toolbox to find out tools we need to use for the evaluation. And we can use the line symbol to connect these two tools. And double click on the blue rectangular, we can set the data source and parameters for this tool. Like this tool is the Reclassify tool we used to evaluate slope data. And now we will add the Reclassify tool to evaluate DM data. Oh, sorry. And we can see that the setting of parameters here is actually the same as what we did by hand. But once we have created the model, we can save it. And whenever we want to use it, we don't have to set these parameters again. And also we can change the name for each of these elements so that we can have a clear understanding about the function of each of step and what kind of tool we used for each of the step. And here we can also set the name of the output in this model. And here, as we have completed the work to calculate and graded all the three factors, here we can combine them together. And also we can adjust the layout of the whole model in this model building window. And now it comes to our final step to reclassify the combined factors. And now, after we change the name of the element, our model is complete, and we can click on execute. We can see that the model is automatically complete all the works we have did by hand. And here on the right, on the left, we can see that it automatically generated all the data set for this evaluation process. And we can see that the result and factors generated in the middle is exactly the same as we did by hand. we can also check the value in this result. And so this model completes the work as we desired. So we can save it, and then we can reuse it if we want to evaluate a different area based on the same evaluation criteria and framework. Okay, that's all for this practice.